In seconds, a single object can change the balance of power. These machines move faster than sound and far beyond sight. Every launch is tracked, measured, and watched across the globe. The result is felt long after the sound has passed. But every missile begins in silence.
The alignment on section 4 is still showing a minor deviation.
We need to recalibrate the gantry before the next rotation.
Few places on Earth are more tightly controlled. This is where modern deterrence is manufactured.
Missiles are built far from cities, in places designed for secrecy and control.
Every movement in and out is monitored with precision. Missile production begins with materials engineered to exact standards.
The caliper reading is consistent at 5.2 millimeters.
Confirmed. The micrometer shows the same on the titanium. I'll log the data now.
Conditions are controlled long before production begins.
Modern missiles are the result of decades of iteration.
Missile production is shaped as much by politics as by engineering. Movement itself becomes part of the system.
Inside, production begins with discipline and precision. The missile's structure begins as separate sections, built to exact tolerances. Every component is shaped for strength, balance, and weight control.
Advanced composites add strength without adding unnecessary mass.
Heat and pressure transform raw materials into rigid structures.
This weld point on the rib looks slightly off spec.
See the discoloration here? Yeah, I see it. Let's check the tolerance with the mirror.
Automation ensures consistency beyond human limits.
Critical joints are verified using advanced imaging techniques.
Specialized coatings protect against heat and environmental stress.
Each section must align perfectly with the next.
Dimensions are verified to millimeter-level accuracy.
Balance is critical long before flight.
Next, propulsion systems are integrated.
Propulsion is the heart of the missile's capability. Each casing is designed to withstand extreme internal forces. Completed units are handled as independent systems. The nozzle directs force with extraordinary precision. Installation requires perfect alignment and timing.
Before flight, propulsion is tested under controlled conditions.
Each test confirms performance without leaving the ground.
Tests reveal stresses invisible during assembly. Small traces can reveal critical performance data.
Systems must stabilize before certification. Only certified systems proceed further. Once installed, propulsion becomes part of the whole. Structure and force are now united.
Next, the missile receives its guidance systems. At the core are systems that determine direction, position, and stability.
Sensors translate motion into data, measured thousands of times per second. Calibration ensures accuracy under constant motion.
Redundant electronics provide resilience against failure.
Signals must remain uninterrupted from launch to flight. Once sealed, these systems are protected from the outside world. Before flight, behavior is tested in thousands of simulated scenarios. Hardware and software are tested together as one system. Systems must survive extreme vibration during launch. Temperature extremes are simulated before approval.
Note the frost line here on connector 3.
Got it. Got it. Data correlates with the stress test results.
Guidance becomes part of the missile's core. All systems are verified together as a single unit. Only certified guidance systems proceed further. Next, the missile is prepared as a complete system. At this stage, every major system has come together.
Power is introduced gradually and deliberately.
Once sealed, the missile becomes a closed system.
Protective finishes complete the exterior.
Balance is verified before any movement beyond the factory.
Transportation requires its own engineered systems.
Once enclosed, the missile is protected from its environment.
Every step is confirmed before release.
Oversight ensures accountability beyond the factory floor.
The missile leaves production, but remains under control.
From here, readiness becomes a matter of policy and time.
Storage is designed to preserve readiness for years, not days.
When movement is required, preparation is precise and deliberate.
Every movement is controlled to avoid unnecessary stress.
Checkpoint 2 secure, approaching the ridge.
Copy that. Keep scanning the high ground.
Deployment facilities are designed for readiness, not visibility.
From here, readiness becomes a matter of decision.
Missiles exist within a wider balance of global tension. Their presence shapes strategies long before they are ever used.
Decisions are guided by data, restraint, and responsibility. The factory continues, regardless of headlines.
For many nations, these systems exist to prevent conflict. Engineering power always carries ethical weight. When the workday ends, the responsibility remains. What is built here is rarely seen, but always present. These places operate far from attention by design.
The impact of this work extends far beyond these walls.
This is how modern missile systems are made.